Have you ever really stopped to think about the incredible power that's just hiding right under our feet? I mean, the kind of raw energy that can shake a whole city to its foundations or build a mountain range from nothing. Well, today, we're going to dive deep into the science that drives our restless and honestly pretty amazing planet. So this is the big question, right? We see these incredibly dramatic events happening on the surface, the ground suddenly shaking or a volcano just erupting out of nowhere. But what's really going on down there? What's the engine driving all this chaos? That is the exact mystery we are going to unravel right now. All right, so to get started, let's just make sure we're all on the same page. Let's put a name to these powerful events we can see and feel. What exactly are we talking about when we say earthquake or volcano? Okay, so an earthquake is basically the planet letting off some serious steam. Imagine, for years and years, immense energy gets stored up in the rock deep underground. It's just building and building, and then all at once, it's released. That release sends shock waves tearing through the ground, and what we feel up here is a violent shake. A volcano, on the other hand, is more like a rupture. It's a weak spot in the Earth's crust that acts like a planetary pressure release valve. It allows all that superheated rock, ash, and gas from way down deep to just burst out and escape to the surface. So we have our definitions, but that's just the what. To really get to the why, we have to go deeper. And I mean literally deeper. The real story, the one that explains everything, starts hundreds of kilometers beneath our feet, with the planet's great tectonic engine. And the key to unlocking this whole thing is a single, powerful idea, the plate tectonics theory. Honestly, this is the grand unifying theory of geology. It basically says that the Earth's surface isn't one solid piece at all. Nope. It's actually a giant jigsaw puzzle of massive, rigid plates that are constantly, and I mean constantly, on the move. Now, this might sound complicated, but there's a really simple way to picture it. Okay, imagine you've got a pot of milk on the stove and you sprinkle some cocoa powder over the top. When you heat the pot, what happens? The hot milk at the bottom rises, spreads out across the top, and then sinks as it cools down, right? It creates a current. And the cocoa powder, it just cracks and gets carried along for the ride. Well, that little kitchen experiment is a perfect model for our planet. The cocoa powder on top? That's the rigid tectonic plates. The hot churning milk? That's the semi-molten mantle flowing beneath them. And the heat from your stove? Well, that's the immense internal energy coming from the Earth's core. This whole process is called mantle convection, and it is the engine that drives absolutely everything on the surface. So what are these plates exactly? Well, think of them as colossal slabs of rock about 100 kilometers thick. They're made of the crust and the very top layer of the mantle. And there are about 10 of these major plates, all floating on a hotter, softer layer below. And get this, they're moving at about the same speed your fingernails grow. Yeah, just a few centimeters per year. A few centimeters a year might not sound like much, right? But when you've got continent-sized chunks of rock grinding against each other for millions of years, well, that's where all the action happens. Pretty much all of the world's earthquakes and volcanoes are happening right at the boundaries where these giant plates meet. So first up, let's talk about divergent boundaries. The name kind of gives it away, doesn't it? This is where two plates are actively pulling away from each other. You can literally think of it as the Earth stretching itself apart. So as these plates separate, magma from the mantle wells up to fill the gap. This process is constantly creating brand new crust and forming these enormous underwater mountain ranges. In fact, the Mid-Atlantic Ridge is the longest mountain chain on the entire planet. It's just hidden under the ocean. On land, the same stretching creates huge rift valleys. This is a zone of creation, and it's marked by lots of volcanoes and frequent but usually shallow earthquakes. Next, we have the complete opposite, convergent boundaries. You guessed it, this is where two plates are on a direct collision course. They're heading right for each other. Now, what happens when they collide totally depends on the plates involved. So, scenario 1, if a dense oceanic plate crashes into a lighter continental plate, the heavier one is forced to dive underneath. This is a process called subduction. It melts rock and fuels these chains of explosive volcanic mountains, like the Andes. But what if two continents collide? Well, neither one wants to give way, so they just smash together, buckling and folding rock upwards to create the most massive mountain ranges on Earth, like the Himalayas, which, by the way, are still growing taller today.
These collision zones create the planet's most powerful earthquakes.
And finally, we have conservative boundaries, which you might also hear called transform boundaries. At these spots, the plates aren't creating or destroying land, they're just grinding past each other, moving side by side. The most famous example of this is, of course, the San Andreas Fault in California. As these two massive plates slide past one another, their jagged edges get snagged and stuck. The pressure just builds and builds and builds, sometimes for centuries, until, snap, it's released all at once in a powerful earthquake. You don't get volcanoes here, but the seismic risk is incredibly high. Okay, so we've looked at all the mechanics, but why does any of this really matter to us? Well, because we live on top of it. These incredible geological forces aren't just some abstract science lesson. They actively shape our world and our lives in some pretty profound ways. And it really is a double-edged sword. The dangers are pretty obvious, right? Destructive earthquakes, tsunamis, volcanic ash clouds that can ground air travel worldwide. But there are also some amazing and kind of surprising perks. That same volcanic ash creates incredibly fertile soil, which is perfect for farming. And the heat from below? We can harness that as clean geothermal energy. Just look at a country like Iceland. It sits right on a plate boundary, and it uses that geothermal energy to provide clean power to nearly every single home. The global impact of these events can be staggering. Just think about this. Back in 1815, the eruption of Mount Tambora in Indonesia was so massive, it shot tons of ash high into the atmosphere. This ash literally blocked out sunlight and lowered global temperatures. The next year, 1816, became known all over the world as the year without a summer, causing massive crop failures and famine all across the northern hemisphere. But here's the really inspiring part. We are getting so much smarter about living with these forces. By studying the very same seismic waves from earthquakes, we can actually map the inside of our own planet. We are engineering buildings that can sway and ride out massive quakes. We're developing incredible systems to monitor volcanoes for even the slightest hint of an eruption. We're slowly learning how to turn a danger into a source of knowledge, clean energy, and valuable resources. Which brings us to a final and kind of mind-bending thought. The map of the world that you and I know, it's just a snapshot in time. The continents are still drifting, mountains are still rising, and new oceans are slowly waiting to be born. It really makes you wonder, if this is our planet today, what in the world will it look like in 50 million years? Because one thing's for sure, the great tectonic engine never, ever stops.